So now we're just going to be solving systems of equations, and we have to come up with the best method that works for us, or one method that does work. So let's review the methods. We know graphing, which isn't always very helpful. We know substitution. Remember, you use that when there's one variable that has a coefficient of 1, or not necessarily 1, but that's when you want to use it. And then there's elimination. You can maybe either add or subtract the equations just as they are, or you might have to multiply them first to get a variable eliminated. So in this equation, we could probably either use elimination, or since we notice the coefficient of the x is a 1, we could use substitution. So I think I'll just use substitution on this one. So I'm going to subtract 2y from each side and get x equals 14 minus 2y. So now I'm going to substitute that back in here where the x is. It's going to say 4 times 14 minus 2y minus 3y equal 12. Now it's just a matter of solving, so distributing your 4, you're going to get 56 minus 8y minus 3y equal 12. Simplifying on this side, I'm going to get 56 minus 11y equal 12. So I'm going to subtract 56 from each side and get negative 11y equals negative 44. Divide by negative 11 and we get y equals 4. So now I'm going to put it back in here for y, and we get that x equals 14 minus 2 times 4, which is 8, so x equals 6. So my solution would be 6 for the ordered pair. And again, you don't have to do it that way. You might choose to multiply this bottom equation by 4 and then use elimination, or something else. You could even multiply by other things and eliminate a variable. So that's going to be your choice to figure out what method you want to use this time. So in this one, since no coefficient does have a variable of 1, we notice the 7s are the same, or actually opposite in this case. So that tells me I probably should add to eliminate a variable. So 3x plus 2x is 5x. Negative 7 plus 7 would be 0 equals 10. Divide by 5, and I get x equal 2. Remember, you can put it in either equation. I'm going to choose to put it in the second equation, so it's kind of 2 times 2. Plus 7y equal 4. 2 times 2 is 4, so I'm going to subtract 4 from each side and get 7y equals 0. Divide by 7, y equals 0. So my answer would be the ordered pair 2, 0. So you might not notice exactly the first step what to do, but think about it and go through the processes and see which method seems to work for you. So here again, there's no variable that has a coefficient of 1, but we do notice these two are the same. So that means we can eliminate them by subtracting the two. 5x minus 3x is 2x. Negative 2y minus negative would become plus positive, and the 2y's would disappear. 12 minus negative 2 would become plus positive, and it would make it 14. So then you divide by 2 and get x equal 7. Again, you can put it in either one. I'm just going to put it in the first one. So it's again 5 times 7 minus 2y equal 12. So this is 35, so I would like to subtract 35 from each side. And I get negative 2y equals negative 23. Divide by negative 2, and I get y equals 23 halves. And you can just leave it like that if you want, or write it as a mixed number. So 7 and 23 over 2 would be our answer, or 11 and a half. Okay, in this problem, as we notice, none of the variables are the same. No variable has a coefficient of 1, so we're probably going to have to multiply. We can either get rid of the x's or the y's. I'm going to multiply the top one by 3. You, again, might choose something different. And the bottom one by 4 to make my x's the same. So it's really up to you what you do. If you choose to do something different, that would be fine. Just make sure you follow all the steps. So we get 12x plus 9y equal 57. And down here we're going to have 12x minus 16y equals 32. So now I'm going to be subtracting them. 12x minus 12x is gone. 9 minus negative becomes plus positive, which would give me 25y. And then over here, 57 minus 32 would give me 25. So divide by 25, and I get y equals 1. Put it back in again, and probably better to go back to the original equation. I'm just going to put in the very first one. So 4x plus 3 times 1 equal 19. So this is 3, so I want to subtract 3 from each side and get 4x equals 16. Divide by 4, x equal 4. So my ordered pair would be the ordered pair 4, 1. And our last example, again this one is already solved for x, so that's probably a good sign that you want to use substitution. You don't have to, but I would suggest you do. So it's going to become 4 times, I'm going to replace the x with a 2y, plus 2y equal 15. 4 times 4 is 8y, so 8 plus 2 is 10y equal 15. Divide by 10, we're going to get a fraction, 15 tenths. Divide both the numerator and denominator by 5, and you're going to get 3 halves. So if I put the 3 halves back in here, it's going to be x equals 2 times 3 halves. The 2's cancel, leaving me just 3. So my ordered pair would be 3 halves.